PDFs are just so bright on my eyes. All right, I think I can just dim my monitor. Oh, hey, didn't see you there. Welcome to page 2 of the 78-page Algebra Readiness packet that I've prepared for you. We're going to go ahead and jump right in here. Remember, just a quick reminder, these videos, if you already know what I'm talking about, this is all review. You can skip on through to the part that you need. These videos are for you to use in the way that benefits you the most. Let's go ahead and get started with problem number 17, where we left off. Transition and scene. Okay, perfect. Find the sum or difference, and it looks like they're all fractions. Number 17 G's. Now, I remember from page 1, we learned about the least common multiple. Okay, now the least common multiple basically is the smallest multiple of that both numbers share. So that's what we're going to use for our common denominator. So basically, we also talked about equivalent fractions last video. If you need to watch that again, feel free to go back and review. We're doing 4/7 plus 3/14, and we're going to make sure our answer is written in simplest form. So what we do when we're adding these two fractions is we actually take the fractions, and in order to add them, their denominators have to be the same number. What is that number? You might ask. It is the least common multiple of the two denominators. Remember, that's the bottom. So it's kind of like if someone had a pizza that was cut up into 7ths and someone had a pizza that was cut up into 14ths, and you ate 4/7 of the pizza and then you ate 3/14 of the other pizza. How much pizza did you eat? Well, you can't just add 4 and 3 because the slices are different sizes. So we need to find a size that works for both. These have already been kind of cut up, so we're going to go ahead and change the bigger pieces maybe a little bit here. So the LCM of 7 and 14, remember you write the multiples of, really what it is you take the bigger number, you write the multiples of the bigger number, and the first one that's divisible by the smaller number is our LCM. So if we're doing 7 and 14, 14 is divisible by 7, so we're actually done, right? 14 is the 14, 28, right? 14 is the smallest number that's in both lists. Remember, there's a bunch of numbers there. So we're going to put 14 in the bottom of both of our denominators here. All right. Now what we're doing is we are writing equivalent fractions. So 3/14, we didn't change its denominator, so the 3 is actually going to come along and not change. So 3/14 is still 3/14, but we did change 4/7. Okay, we changed 4/7. We turned it into something over 14. Since the denominator is 2 larger, right? It was the second multiple. We're going to multiply the top by 2 as well to keep it the same. 7 times 2 is 14. 4 times 2 is 8. Now that our two fractions have the same denominator, that is, the pizza slices are the same size, we can go ahead and add their numerators. 8 plus 3 is 11 over 14. That's our answer. 11/14 there. Bingo. Bazinga, whatever word you prefer. Let's go ahead and do number 19 next, and then we'll tackle these mixed numbers. Okay, let's do this thing. Number 19 is 9 over 10 minus 4 over 5. 9 over 10 minus 4 over 5. Okay. LCM, sometimes you can reduce fractions. We can't really reduce these, so they're both in simplest form. Let's go ahead and find the LCM of 10 and 5. That is, you might guess. So if you write out the multiples of 10, 10, 20, and then 5, right? 5, 10. Hey, look, there's our LCM. Perfect. So 10 here, 10 here. This one did not change, so that will stay 9/10. And then 4 over 5, we multiplied the denominator by 2, so we also must multiply the numerator by 2. to get 1 over 10. Great. Now this is in simplest form. We can't divide the top and bottom by anything to make it simpler. Super duper red. We're going to switch to red. Okay, now we're doing 6 2/3 plus 3 4/5. Now, if it's been a while since you've done mixed numbers, I'm actually going to do this problem 2 ways, and I'll let you guys kind of choose and strategize which way you like. Again, don't feel like you have to watch everything in here, just the stuff you might need to review. Way number 1 is I'm going to think about, because what 6 2/3 means is it really means 6 plus 2/3. And what 3 4/5 means is it really means 3 plus 4/5. Okay? So one way to do this and keep our answers exact, so you could use decimals, but I'm going to use fractions. You can think about it as 6 plus 2/3 plus 3 plus 4/5. And there's this rule called the commutative property of addition that says we can add in any order. So I'm going to do 6 plus 3 first. I'm going to kind of change the order of the addition that we are doing. Plus 2/3 plus 4 over 5. That'll give us 9 plus, now I have to add these two fractions together. That is going to be a common denominator or the least common multiple of 3 and 5. I'm not going to take the time to go and do that. I'll let you guys take your own time to do that now so we don't have to do it on every single problem. But the least common multiple of 3 and 5, I believe, is 15. Okay, so 15, it's going to be something over 15 plus something over 15. 2/3, 3 times 5 is 15, 5 times 2 is 10, so this is 10/5. 2/3 of 15 is 10. And 5 times 3 is 15, so I'm going to multiply the top by 3 to get 12. We're going to add those together. And you end up with 9 plus 10 plus 12 is 22 over 15. Now we got a problem here. 22 over 15 is more than 1, so I can't just tack this number onto 9. What you actually have to do is you're going to kind of think about breaking that apart. That is, I'm going to write this as 9 plus 15 over 15, which is 1, plus, let's see, what would that be, 7 over 15. So what I just did is I took 22 over 15 and I pulled out 15 of the 22 to make a whole. So 15 over 22 is 1 whole pizza in this case. We'd have 7/15ths left over from the 22, which since 15 over 15 is just 1, this is just 10 plus 7 over 15, or 10 and 7/15ths. I like this method. Now, I don't expect you, if you were to do this on paper, wouldn't expect you to write necessarily every little step. Like, I don't think you need to write all those. You probably skip a couple of these in the way that you're doing it. Okay, another way you can do this is you can change the, I'm not a huge fan of this method, but you can change these mixed numbers into common fractions, which is just one number over the other. So if each whole is 3/3 and we have 6 of them, that would be 18/3 just from the 6 plus an additional 2. So the trick that you may have learned in school is take the denominator, multiply by the whole, and then add the numerator. So that would be 3 times 6 is 18 plus 2 is 20. So it's 20/3 plus, now this method gets nasty, right? 5 times 3 is 15, but it works. 15 plus 4 is 19 over 19 over 5. You keep the denominator that was in the fraction. Okay, so if we're going to add these two together, this is where it gets kind of brutal. If we're going to add these two together, we need a common denominator. It's the same thing. It's 15. Yuck, the math here is pretty brutal. We multiplied this times 5, so you multiply that times 5. 20 times 5 is 100. Multiplied this by 3, so we multiply that times 3, which I believe is 57. Oh, that's not too bad. Add the two numerators together, and you'll get 157 divided by 15. and then basically 150, 15 times 10 is 150. So that's where you do your division here to get. So technically this answer is correct. I mean, this is the right number. But if you write it as a mixed number, you'd have to kind of do math again to write it as 10 and 7/15, or do division and get a remainder. Okay, that's a lot of work. This method requires usually less brutal math. So let's go ahead and take a look at number 20. Ooh, yeah, this is gonna be good. 8 3/4 minus 4 5/6. All right, I'm gonna do this one both ways as well. Again, you don't have to watch both. Way number one would be to kind of think about doing the subtraction first. So what we have going on here, it's really what we have is 8 plus 3/4, right, minus 4, but you're subtracting the 4 and you're subtracting the 5/6, so it's minus 5/6. And here's what's kind of a problem here. We can't do 3/4 minus 5/6 because 5/6 is bigger than 3/4 when we do this subtraction. So what we're going to do here is I'm actually going to change this up. I'm going to kind of borrow from the 8, and I'm going to borrow a couple fourths. So how I'm going to do this is I'm going to think about this as 7. Okay, I took a whole away. I took 4/4 away, plus 3/4 minus 4 minus 5/6. So 4/4 is just 1. 1 plus 7 is 8. So we haven't done anything except I just took 4/4 or 1 away from that 8. And I'm doing that so that I can create a fraction that we can subtract 5/6 from. So you'll have 7 and, let's see here, 7 plus 7/4 minus 4 minus 5/6. Yeah, I like that. Okay, now 7/4 is bigger than 1, and this is less than 1, so I know I'll be able to subtract and I'll be in good shape. Okay, let's do 7 minus 4 first. Let's do the whole numbers. That gives us an answer of 3. And then all we have left to do is figure out what 7/4 minus 5/6 is. Now we need a common denominator, or the least common multiple of 4 and 6, and that is 12. Okay, so this fraction is going to be 7/4. 4 times 3 is 12, so the top times 3 is 21. Let's see here. And then 6 times 2 is 12, so we're subtracting 10. Perfect. So now we can do this. Now we have a bigger number minus a smaller number. If we had done it before with 3/4, it would have ended up being 9 minus 10/12, which would have been kind of a problem. Okay, so we get our final answer then will be 3, and 21 minus 10 is 11/12. Interesting. Let's do it the other way. Let's think about this. Let's try converting them first. 4 times 8. Good mental math here. 4 times 8 is 32, plus 3 is 35/4. Okay. Minus 6 times 4 is 24. 29/6. Okay, now we know the common denominator is 12. So it's something over 12 minus something over 12. 4 times 3 is 12. So we're going to do 35 times 3. 30 times 3 is 90. And 5 times 3 is 15. So 90 plus 15 is 105. I think I did that right. Yeah, I got her. Okay, and then the next one is times 2. 29 times 2 is going to be, let's think about that, 58. So that'll be 58/12. Okay, and now we can subtract and do 105 minus 58. Oh boy, I really bit off more than I could chew here. So let's do minus 60. Let's see, or I'm just doing mental math here. Whichever method works for you for subtraction. I'm using my Dart math here. Minus 60 plus 2 is the same as minus 58. 45 plus 2 is 47. Hopefully I did my math right there. 47 over 12. That makes sense because 48 over 12 is 4, and we are 1/12 short. So there's your 3 and 11/12. Ugh, that was nasty. I think this method is superior for mixed numbers. You can also just do decimals. That is an option. If you're trying to get an answer fast, write it as a decimal, do the subtraction, get your answer. If you're trying to make your answers exact, it's the method that you use. Okay, cool. Let's go ahead and move on. Yeah, so check this out. We got integers here, right? Integers are, you may have, I always kind of go through this spiel, but like back in the good old days when there was just sheep and you were counting sheep, the natural numbers that occurred were 1, 2, 3, 4. You could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sheep. That kind of made sense. So these are called the natural numbers. But eventually people needed to start borrowing sheep, and people had debts. So, people invented the negative numbers. You had your 1, 2, 3. I think they were probably actually invented for terms of mathematics standpoint, but you had negative numbers. These are called integers, okay? I guess these are the whole numbers. I can't remember. One of them's got 0, one of them doesn't. And then integers has 0 and all the negative versions, right? So what's the rule for adding integers? Like, how do I add negative and positive numbers? The best way to explain it from a math teacher standpoint is from the terms of good guys fighting bad guys. Anything that is negative, we will consider a bad guy. Anything that is positive, we will consider a good guy. And those armies are going to kind of rush at each other, and anything that is good is going to take out something that's bad, and vice versa. So when I say 6 plus negative 3, by the way, you can write 6 plus negative 3 in many different ways, and they're all going to have the same answer. Okay, I see this as an army of 6 good guys fighting an army of 3 bad guys. You could also, maybe they're on different sides of the field, you could write it as an army of 3 bad guys fighting an army of 6 good guys. Good guys are on the right. You can also write it like this. You could write it like 6 minus 3. That also is the same thing. You don't need that little plus there. All of these represent the same problem, okay? You have an integer positive 6 being added to an integer that is negative 3. Army of good guys, army of bad guys, and that army method works with adding and subtracting integers only. So anyways, who's going to win this fight? There are more good guys, and there are 3 more good guys than there are bad guys. So our answer is positive 3. The good guys win, and there are 3 of them left. Let's see a couple other examples. Moving on. Let's grab purple here. So like how about negative, let's do negative 4 minus 6. Okay, so maybe it's kind of foggy, and you've got an army of bad guys, and they see somebody across the field, and they're charging across, and they see it, and they're like, these guys are also bad. They're like, Bill, Steve, I know you. Weren't you at camp or whatever? And they're going to be like, we shouldn't fight each other. Let's join up. So these guys are not going to fight. They're going to join forces of evil to fight good later. So that's going to be, you'll have a group of 4 bad guys and a group of 6 bad guys. They're going to join up to make a group of 10 bad guys. All right. 23 and 24, let's do those. Sometimes you'll see problems, negative 5 minus negative 13. Sometimes you'll see problems where you have this double negative situation going on, or maybe there's parentheses, maybe there isn't. This really says opposite. So it's like the opposite of a negative is actually a positive. So this, we can't do the good guy, bad guy metaphor. until we write it in its simplest form. The opposite of negative 13 is positive 13. So this scenario is you have an army of 5 bad guys fighting an army of 13 good guys. Who's going to win? The good guys. There's more of them, of course. How many more? Well, there's 8 more. So 5 of the bad guys, you can take out 5 of the good guys. You got 8 good guys left over. That's our answer. And then negative 7 plus negative 1, army of bad guys are going to join up and it's going to give you negative 8. Okay, well, it turns out that that same rule applies for decimals. So let's go ahead and take a look at some of these decimal rules and for fractions. So we're going to look at that and then we'll get into multiplication and division. Kind of went over the ones on the bottom. Okay, we're just going to work through these and then you guys let me know when you're ready. Again, these videos are going into great length, so feel free to skip around to the ones that you need. If you have negative 4.51 plus 11.65, same kind of thing applies. You have 11.65 good guys, if that's possible, and you have 4.51 bad guys. Good guys are going to win, so we know that the good guys are going to win and that our answer is going to be positive. We know that they're going to fight, and fight really means subtract. So we can subtract 4.51 from 11.65, and we won't need to do any borrowing or anything here. So that's going to be 4 minus 7.14. That's our answer. Okay. 11 minus 4. There gives our 7. 6 minus 5 is 1, so on and so forth. Check my work with the calculator if you want. All right, let's keep on cruising. 8.5 minus negative 7.9. All right, we're getting there. Not simplified, we have a double negative, so I'm going to change that. And in this scenario, you have a group of good guys that runs into a group of good guys. So we're going to do 5 plus 9 here, or 5 plus 9 for the decimals. So really, back in the day, you would have lined this up, 8.5 and then 7.9 like so. That's going to be 14. Carry the 1, 15, 16, and drop the decimal down, 16.4. Looks good to me. That's our answer. All right, let's do some fractions, and I'm going to try and go through these a little bit faster since you've seen some of them. So 3/10 minus 3 over 4, common denominator there. The least common multiple of 10 and 4. Well, 10 is not divisible by 4, so go to 20. And 20 is divisible by 4, so we're going to write them, that's the next multiple of 10. We're going to write that as something over 20 minus something over 20. 10 times 2 is 20, so multiply the top by 2, which will give us 6. 4 times 5 is 20, so we're going to multiply the top by 5 to give us 15. Okay, this one's a little different. We have, again, you're just focusing on the numerators when you do the subtraction. You have 6 minus 15, good guys and bad guys. Bad guys are going to win here because there are 15 of them. And they are going to win by 9. So the answer is negative 9 over 20. Okay, negative 9 over 20, it's the same thing as writing negative 9 20ths. There's our answer. Super. And the last one, 1/5 plus negative 2/3. All right, common denominator, 3 and 5. That's going to be 15 again. Multiply by 3. 3 to 15 is 5. Multiply, that's going to be 10. So this is 3 minus 10, which will give us negative 7/15. Super. All right, now, so what's the rule when multiplying integers? Oh, these are some funky ones. We got lots of rules going on here. what's the rule for when you are simplifying and let's say just multiplying fractions or numbers that are negative and positive? Now, we can't use the good guys, bad guys metaphor when you're doing multiplication and division. I always use the agree, disagree metaphor. If that works for you, great. Use whatever works for you. But the first one is negative 85 with a division symbol divided by negative 5. Now, you can write that. That is, writing division like this, you can also write it as a fraction. So that's what I'm going to do. And a negative divided by a negative, or a negative times a negative, is always going to be a positive because the signs agree. Just like a positive times a positive is a positive, and a positive divided by a positive is a positive. Your answer will only be negative when the signs are different. Okay, so since the signs are the same, our answer is going to be positive, so we know that. And then all we have to do is focus on what is 85 divided by 5. That's 1, 5 minus 3, 5, 7, 17. The answer is positive 17. Okay, great. So the signs agree, which means we'll get a positive answer. Let's go ahead and do number 30 next. Let's do all the ones that are just integers first, and then we'll move on. Oh yeah, this is good. We can do 30. We got it. All right, so 30 is 7 times negative 6 over 14. So 7, do we multiply the top, the bottom, or both? Well, once we write this, the rule for fraction multiplication, let's go and just do a simpler one. If I want to do like 3/4 times 10, oh, we've got one down there. Let's just do that one. Let's jump to number 33 really fast and do that. So 33 is 6 over 5 times 5 over 9. Okay, so the common way I see people simplifying fractions, I'm going to show you the way I see a lot of people do it, and then I'm going to show you the way that I think about it. So I guess we'll do it kind of two ways here for simplifying fractions. I know I'm going out of order. One way that I see people do it is they'll multiply and then simplify, and that actually makes the problems more complicated. So if you multiply first and you get 30 over 45, you're now stuck with trying to find the greatest common factor of the numerator and denominator so you can simplify, and that takes time. So I think the best strategy here is to cancel things that are in the numerator and the denominator before you multiply. And the way you may have learned is that you got a 5 in the top, you got a 5 in the bottom, you can cancel across. That works. The way that I really like to do it is think about all the numbers prime factorizations in the top and the numbers prime factorizations in the bottom. So you think about 6, for example. So the rule for multiplication, remember, is you multiply across the top, multiply across the bottom. Okay. So for multiplying fractions. Okay, so let's multiply across the top. That's 6 times 5, right? I wouldn't necessarily expect you to show this work, but that's okay. Now what we can do is, so here for our GCF, I think, what is the GCF here? I think it is 15. We can divide each of these by 15, but that's not super obvious. All right, you have to really work to try and simplify these. Makes more sense to break stuff apart. 6 is 2 times 3 times 5. And then the bottom, we can't break apart 5, but we can break apart 9 into 3 times 3. So now what we can do is we can cancel the things that are in both the top and bottom. A 3 cancels, a 5 cancels, and we get the answer 2/3. Way less math required. Way less math required here, and we'll get the same answer as if we found 15 is our GCF and divided by 15, or if you sit and divide by 5 and then divide by whatever works for you. This method is the simplest. I'm convinced, at least. So the answer for number 33 is 2/3. So let's jump on back to this number 30. So 7 times negative 6 over 14, we're going to write that as 7 over 1. So to do fraction multiplication, you need to write 7, which can be expressed as a fraction, and then you just pick a side for the negative to go on. So I'm just going to put it up top. It doesn't actually matter as long as you don't put it in both. Okay, on the top or bottom. And now let's break these apart so we can simplify. So you could cross cancel here and simplify 7 over 14. That would simplify to 1/2. If that's the method that you like to do, be my guest. 7 over 14 simplifies to 1/2. I like this way because the way that I was doing before, because it shows things kind of breaking apart. So so it's going to be, let's call this, the whole top is going to be negative. So -7 times 2 times 3 for 6. Okay. Then on the bottom, you just have 2 times 7. So what's going to cancel? We're going to cancel the 2. We're going to cancel the 7s. All you got left is a 3 in the top. So you get the answer. -3 over 1, which is just -3. Another way you could think about this question is do 42, multiply across the top, 42 divided by 14. But I really like this canceling method quite a bit. Super. All right. Fantastic. 31. Let's keep going. 31 says 4 squared times -6 squared. So what an exponent means, let me remind you, is the number of times that number is multiplied. When we write two numbers with exponents next to each other, we are multiplying those numbers. So if you were to expand this out, this would be 4 times 4 times -6 times -6. A common mistake here is to just make this -36, but it's actually not -36 because the negative is inside the parentheses that are being squared. So it's 4 times 4 times 6 times 6. So when we're multiplying these out, you can kind of do them in sections like so, and then multiply the result of those two multiplications. 4 times 4 is 16. -6 times -6 is +36, and we've got ourselves quite the multiplication here that we're going to have to do. I trust you can do this in a calculator. Since the rules on the top of the sheet said no calculators, I'm going to do it long ways, and it's going to be lots of fun. 6 times 6 is 36. 6 times 3 is 18, 19, 20, 21. Okay, and we're going to come over down here. 1 times 36 is 36. Add the result, 6, 7, 5, 576 is our answer. And you can check your work on a calculator if it's been a while since you've done one of those multiplications. Boy, we are tackling quite a bit of information here. All right, got her done. Okay, 32, let's go on. 32 is 22 divided by -8. Okay, so let's write that as a fraction, and then we're going to simplify that. It is a positive divided by a negative, so that means our answer is going to be negative. And then we just need to simplify 22 over 8. Turns out they're both divisible by 2. Divide them both by 2 and you'll get 11 over 4. If you wanted to write that as a mixed number, we can subtract 4 from 11 twice, and you'll end up with -2, and 11 minus 8 is 3 quarters, -2 3/4. All right, let's keep on trucking. Let's do 34, 35, 36, and call it good. Yeah, let's do 34 here. Here is question 34. So the rule for, remember, the rule for multiplication is to, what I did here is I broke these numbers apart and then canceled the factors that were in the top and bottom. But really the rule is multiply across the top, multiply across the bottom. That's what we did in both scenarios. I canceled, then multiplied the remainder, okay? The rule for division is slightly different, but very similar. What I was always taught, or the trick that I learned rather, from some students, the phrase that I learned was skip, change, flip. So when you're dividing fractions, you skip the first fraction, you change multiplication to, or change division to multiplication, then you flip the fraction. By flip, it really just means provide the reciprocal of that fraction. Some mathematical verbiage, okay? 7 over 3. All right, change division to multiplication and flip the fraction, which would be the reciprocal of 5/2 is 2 over 5. Okay, and now that was a positive. So right here we have a negative number times a positive number. A negative times a positive, these signs disagree. So that means our answer is going to be negative. So our answer is going to be negative, and we'll worry about the numbers later. Nothing here is going to cancel. I can't, all of these are primes. So I can just do, it's negative 7 times 2 is 14 over 15, and that's my answer. Whoa, try that again. Negative 14/15. Right, moving on. Negative 2 over 9 times, in parentheses, negative 3 over 8. Okay, so here we have a negative times a negative. And so when we're doing a negative times a negative, we know the answer is positive, so we actually don't have to worry about the negative signs at all. Okay, so let's go ahead and I'm going to break down and then multiply like I did before. I really like that method. So 2, we're just going to multiply across the top. 2, and again, I'm dropping all the negative signs because a negative times a negative is a positive. All right? 2 times 3 in the top. And then 9 is 3 times 3. And 8 is 2 times 2 times 2 when you break that down. Okay? 2 cancels with a 2. 3 cancels with a 3. 2 times 3 is the same as 2 times 3 times 1. So I can throw a 1 up there. And you end up with 1 over, multiply what's left in the bottom, 3 times 2 times 2, which is 3 times 4, which is 12. 1 over 12. All right, this one's going to be good. I'm excited. 2 and 2 sevenths divided by 3 and 3/4. Let's go ahead and jump on this. So let's write each of these as a common fraction first. So that's 2 times 7, which is 14 plus 2, is 16 over 7. Keep the denominator. Divided by, so we don't want to do the skip, change, flip first. We want to put them in common fraction form first. 3 times 4 is 12, plus 3 is 15 over 4. Okay, now we can do that skill that we practice. Skip, change, flip. Skip the first, leave it as 16 over 7. Change division to multiplication, flip the fraction. Man, who came up with these numbers? They're insane. Okay, 16. Let's break this apart. And is anything going to cancel? So that's a 2, right? 2 times 2. 4 is 2 times 2. 15 is 3 times 5. So there's no 2's in the bottom. So breaking apart 4 isn't going to make a difference. 16 is 4 times 4, and the 4's are just 2 times 2 times 2 times 2. So there are no 2's in the bottom, so it doesn't make any difference breaking those apart either. So what this means is we can actually just multiply across the top, multiply across the bottom, and we'll be in good shape. 16 times 4 is 64, and 7 times 15, my goodness, that's a large number. 15, 7 times 10 is 70, 7 times 5 is 35, so that is 105. Does that seem right? That does seem right. Okay, so 64 over 105 is our answer. Cannot be simplified because nothing was going to cancel in that multiplication. All right, right. Improper fraction and common fraction are kind of synonymous. So we're going to write this as an improper fraction, and we're going to wrap it up with these two problems that should be very quick. Again, so I want to spell that out one more time in case you forgot. If you're flashing through the video, let's write that even bigger. I'm going to write it huge. 4 3/4. Okay, the rule is start at the denominator, times by the whole number, and add, and then keep the denominator when you're done. So 4 times 4 is 16, plus 3 is 19/4. Okay, and 38, 37, or 38/7. Okay, if we want to write this as a mixed number going the opposite direction, the way that I think about it in my head are the multiples of 7. So I know like 7 times 5. So go through the multiples. 7 times 4 is 28. Okay, 7 times 5 is 35. 35 is only 3 away, and 7 times 6 is 42. 42 is too big, and 35 is just small enough. So I could write this as 35/7 plus 3/7 to get 38/7, and 35/7 I know is 5. So this is just 5 3/7. Okay, that's it for video number 2. That was a long one. Thanks for watching. Video part 3 will be coming soon.